Good day, viewers. This is Ademola Johnson, your science tutor. In continuation of the topic electronic configuration, we want to open up a fresh topic in which electronic configuration is a precursor, is a foundation that must be had before one can enjoy the topic, and the topic is periodic table. So let's go. I remain myself, Ademola Johnson. Please share this video, like it, and go to my YouTube channel titled Ademola Johnson and get catalogs of videos that can help you academically. We have about over 90 videos now. So, periodic table. What is periodic table? Periodic table. Periodic table. A periodic table is a tabular arrangement of chemical elements in order of atomic number, and in order of reoccurrence, and in the order of reoccurrence of similar properties at intervals. Now, this is the comprehensive definition of periodic table. A periodic table is a tabular arrangement of elements in order of atomic number, in the order of atomic number, and in the order of reoccurrence of similar properties at intervals. Let's look at short history of periodic table. Now, the first man to construct the periodic table in 1896 was a Russian chemist called Dmitry Mendeleev. Dmitry Mendeleev was the first chemist to construct the periodic table. But there are two challenges his periodic table had. So, the periodic table constructed by Mendeleev had the following two challenges. Number one challenge is that elements were arranged in increasing order of atomic mass rather than atomic number. What are we trying to say? You see, when Mendeleev constructed his periodic table, he told us that the elements there were arranged in increasing order of atomic mass. But some controversies came when the issue of isotopy came, that it is possible for you to have two or more than two elements, two atoms of the same element, having the same atomic number, but they have different mass numbers. Then, that led Dmitry Mendeleev to construct the periodic law, where it was clearly stated that elements in the periodic table are rather arranged in increasing order of atomic number and not atomic mass. Another challenge, it was that now the Dmitry Mendeleev periodic table had gaps. The periodic table Mendeleev constructed had gaps. That is, there were some holes that elements were supposed to be put and elements were not put. They were empty. Why? Now, this was because the elements that could occupy the gaps were not yet discovered as at the time of the invention of Mendeleev periodic table. So as at the time Mendeleev constructed his periodic table, those elements like germanium and so on, they were not yet discovered. And when he constructed it, he kept their spaces. He kept their spaces. Those elements were not discovered. He left their spaces there. So we now began to have gaps in his periodic table. But he did something wonderful. Now, Mendeleev proposed the properties of the elements that would later fill up the gaps in his table. Anytime they would be discovered. What am I trying to say here? Mendeleev did not just leave those spaces empty, but he stated that in case he died before those elements will be discovered, these are the properties of these elements. He stated those properties. But wonderfully, as at the time those elements were discovered, they had similar properties earlier stated by Mendeleev. So, now, as at the time, the elements were discovered, what happens? They had similar properties stated earlier by Mendeleev. So they had those properties stated by Mendeleev. Now, yes, if they might ask you, I've seen a question, they say, state two challenges that confronted the periodic table constructed by Mendeleev. We have stated them. and state how those challenges were tackled. We have stated one. We said elements were arranged in order of increasing atomic masses. The military made the length periodic table had gaps. We have stated the solution. It had gaps, but it gave us a solution, the properties of the elements that will fill up those gaps as at the time they will be produced, and it were so. That was one solution. Another thing now to tackle the problem of the first challenge. Now, Dmitri Mendeleev later realized that the most reliable property for the arrangement of elements in the periodic table is increasing order of atomic number rather than atomic masses. Then what did he do? He then established the periodic law. So when he knew that he had made a mistake by stating that the properties of elements in his periodic table are in order of increasing atomic masses, and he realized later that atomic mass is not reliable. We also have a situation where two elements have the same atomic masses. Yes, we call it isobar. So it's possible for two elements with different symbol of atoms to have the same mass number. So mass number is not reliable. He realized that atomic number is better used than mass number. And because of that, in order to correct his mistake, he stated the periodic law. What did the periodic law say? Periodic law. Now, the periodic law states that the properties of elements in a periodic table are the periodic function of the atomic number of the elements occupying the periodic table. So he has corrected his mistake by stating the periodic law. He said that the periodic law says that the properties of elements in a periodic table are the periodic function of the atomic number of the elements, not periodic function of the atomic mass, as earlier stated by him. Next, we also have two other contributors. Now, so we also add two other contributors to periodic law. So they also make contribution, but scientists did not look too much on it. So other two contributors to periodic table two contributors to periodic table are, first person is Julius Mayer, Julius Lothar Mayer, and J. So now, J. Lowlands. So we have two other contributors are Julius Lothar Mayer and John Lowland. Now, Mayer, what did Lowland says? Now, according to John Lowland, if elements in the periodic table are arranged in the order of atomic mass, comma, there would be a reoccurrence. There will be a reoccurrence of similar properties. Similar property at the interval of 8. So this law was regarded as the octave law. Octave law provided by John Lowlands. He said that yes, he wants to support Dimitri Mendeleev by saying that elements in the periodic tables are arranged in increasing order of atomic masses. But he said if it were to be so, that there will be reoccurrence of the same properties at the interval of every 8 elements. Like when you have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. So at every 8 interval, you'll be having the same property, So that is what he said, and that law is called what? Octave law. Then Julius Mayer stated that the elements in the periodic table are arranged in the order of atomic volume. I don't know where it came about that. Atomic volume. So, but both the work of Mayer and Lowlands they did not gain too much of attention like the work of Dimitri Mendeleev. So scientists submitted to using the work of Dimitri Mendeleev than the work of Lowland and Mayer. So that is about the short story of the periodic table. So in the next video we are going to watch, we are now going to talk about the idea, how to construct the periodic table and state out some properties or criteria used in classifying elements in the periodic table. See you in the next video. I remain Afe Ademola Johnson. See you at the top. Please do study. If you are informed, you will not be deformed. This age we are is information age. Certificate has failed a lot of people, but what is working for a lot of people now is sabiti case. What you sabi, sabiti case. So please work hard to sabi rather than to sati. God will help you. So please try to share this video, like it, and subscribe in my YouTube channel titled Afe Ademola Johnson. God bless you and bye for now. Thank you.